In this video, we present Xplorer, an interactive visualization system that is designed to query, analyze and compare the classification output of activity detection tasks in multi-sensor data. Xplorer visualizes the results of different classifiers, as well as ground truth information, as temporally aligned linear tracks. Through coordinated TARC visualizations, video synchronization and the definition of a TARC algebra, Xplorer enables users to interactively explore and compare the results of different classifiers and assess their accuracy with respect to ground truth labels and video. In this video, we consider the classification results obtained from the sensor data collected during a session of 51 minutes, in which a patient with Parkinson's disease performs a set of different tasks. In the so-called protocol track, we can observe the time range in which the sensor data was collected, in this case roughly ranging from 10 am to 11 am. The protocol track may display different event labels on the same timeline for temporal reference, and in this case, we can observe the name and duration of the tasks performed by the subject, and we can perform zooming and panning for more granular inspection. While mouse hovering, a coordinated video shows the activities performed by the subject. On top of the protocol track, there are two main types of track: classifier tracks and label tracks. From the left sidebar, let's add the first version of the walking classifier, developed by the data scientist Avner. Here, each colored block represents a prediction, where the intensity of the color indicates the probability of the subject performing a particular activity. A classifier track can also be visualized as a probability area chart, which shows how the choice of the classifier threshold impacts which events are detected. Similarly, label tracks are visualized as green blocks and often represent ground truth labels, in this case manually annotated by a human. In order to combine the information contained in different tracks, we provide an algebraic language that enables to perform common arithmetic and logical operations over classification results and labels. Let's consider this example in which walking ground truth labels have been generated as two separate tracks, which we would like to combine in a single one. From the command line, with the help of autocompletion, we can add the two tracks to generate a new one. It would be useful now to observe which events are misclassified by the walking predictive model. To start, we can identify all false positives by subtracting the ground truth track from the classifier track. The newly generated track will now contain only the events incorrectly predicted as walking. By playing the track, we can easily observe all the false positives and reason on the fact that they are all related to intense movements of the chest of the patient. The walking classifier, in fact, was using only the sensor on the chest to perform its prediction. Similarly, we can quickly identify false negatives by subtracting the classifier track from the ground truth label track. In this case, we obtain a new track containing all the walking events that were not identified by the specific classifier. By visually matching the blocks or by watching the video, we notice misclassifications correspond to the initial or final part of each walking event. From here, we can for instance assume that lowering the classifier threshold would increase the prediction accuracy. Classifier tracks can be visually compared to evaluate their performance. In this example, we can observe two different classifiers which detect when a person is turning. By taking a look at the green ground truth labels, we can see that the first classifier detects turns with a lower probability, but also that the second classifier seems to predict them too early in time. Similarly, we can check the alternance of detected turns and walks together with the identified steps. Instead of just allowing a visual comparison, Xplorer also incorporates the most common performance metrics in a dedicated view. Here, a classifier track can be evaluated against another track, showing metrics such as Jacquard index, accuracy, precision, recall, and F1 score. When applicable, an interactive ROC curve is displayed, showing how the choice of the threshold influences the amount of misclassifications.